I am P. Gomati, Assistant Professor, Department of Mathematics. So in this lecture we are going to see about double integration in Cartesian coordinates. So let me see the first problem. So evaluate integral 0 to 1, integral 1 to 2, x into x plus y into dx dy. So which is equal to, first let us evaluate the inner integral, that is integral 0 to 1. When you multiply x into x, you get x square, and plus x into y is xy dx dy. So you have to differentiate x square with respect to x and xy also with respect to x. So when you differentiate x square, you get x cube by 3 plus y into, when you differentiate x, you get x square by 2, and the limit is from 1 to 2 into dy. So when you substitute the upper limit 2, you get 2 cube, that is 8 by 3, minus the lower limit 1, you get 1 by 3, plus y into, when you apply the upper limit 2 square, that is 4, minus lower limit is 1 square is 1, so y by 2 into 4 minus 1 into dy. So after simplification, you get 2 by 3 plus 2y minus y by 2 into dy. This you have to integrate with respect to y. So when you integrate 7 by 3, you get 7 by 3 into y plus 2 into, when you integrate y, you get y square by 2 minus y square by 2 into 2, that is 4, upon the limit 0 to 1. Again applying upper limit and lower limit, you get 7 by 3 plus 1 minus 1 by 2, and upon simplification you get 37 divided by 12 is the answer. Now the second problem, evaluate integral 0 to 3, integral 0 to 2, e power x plus y into dy dx. So let us split this integral, that is e power x into e power y dy dx. When you integrate this, you get e power x plus y between the limit 0 to 2 into dx. So for upper limit you get e power x plus 2, minus for lower limit you get e power x plus 0. So e power x plus 2 minus e power x into dx. So when you integrate this with respect to x, you get e power x plus 2 minus e power x upon the limit 0 to 3. When you apply the upper limit, so e power 3 plus 2 minus the lower limit is e power 0 plus 2 minus of e power 3 minus e power 0. So the answer is e power 5 minus e power 3 minus e power 2 plus 1. Next, the third problem, evaluate integral a to b integral 2 to b integral 2 to a dx dy divided by xy. So first let us split this integral, that is dx by x is one integral and dy by y to be the another integral. First let us integrate dx by x. So integral of dx by x is nothing but log x between the limit 2 to a. So when you apply upper limit log a minus the lower limit is log 2, which is a constant, let us take it outside. So log a minus log 2 into integral 2 to b dy by y. So integral dy by y is nothing but log y between the limit 2 to b. So log of b minus log of 2 into log a minus log 2. So log a minus log 2 can be written as log a by 2 using the property log m minus log n is equal to log m by n. Similarly, we can write log b minus log a to be log b by a. So this is our solution, that is log of a by 2 into log of b by 2. Next one, fourth problem. Evaluate integral 0 to a, integral 0 to root of a square minus x square into dy dx. So since the inner limit is with respect to x, you have to integrate first with respect to y. That is here dy, when you integrate you get y between the limit 0 to root of a square minus x square into dx. So the upper limit is root of a square minus x square minus the lower limit is 0 into dx. So how will you integrate this one? So this you have to integrate using the formula integral root of a square minus x square into dx is equal to x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a between the limit 0 to a. So when you apply the upper limit, it will be 0 because, so the first integral will be a by 2 into root of a square minus a square, that will be 0. And for lower limit also, the first term becomes 0 because x is outside. When you put 0 for x, the first term will be 0. So for both upper and lower limit, the first term will be 0. And in the second term, when you apply the upper limit, you get a square by 2 into sine inverse of a by a. So a and a gets cancelled, you get sine inverse of 1 minus Lower limit is a square by 2 into sine inverse of 0 by a. So 0 by a is 0 and sine inverse of 0 is nothing but 0. So our answer is a square by 2 into sine inverse of 1. So when sine is 1, so at 90 degree only sine will be 1. So 90 degree is nothing but pi by 2. So a square by 2 into pi by 2, which is pi a square by 4 is our answer. And the next problem, evaluate integral 0 to 1 integral 0 to root of 1 plus x square into dy dx divided by 1 plus x square plus y square. So this you have to simplify using the formula integral dx by x square plus a square equal to 1 by a into tan inverse of x by a. So here our a square is nothing but 1 plus x square, that is root of 1 plus x square is our a square. So you have to rewrite this equation. So integral 0 to 1 integral 0 to root of 1 plus x square dy divided by, so instead of writing 1 plus x square, we can write it as root of 1 plus x square the whole square plus y square into dx. So that this will be our a square is nothing but root of 1 plus x square the whole square, and in the place of x square you are having y square, and in the place of dx you are having dy. So just replace x by y and a by root of 1 plus x square in the given formula. So what is our formula? Integral dx by a square plus x square equal to 1 by a. So our a is root of 1 plus x square into tan inverse of x by a. So in the place of x you substitute y divided by a is nothing but root of 1 plus x square, and between the limit 0 to root of 1 plus x square. So when you apply the limit, upper limit, so tan inverse of root of 1 plus x square divided by root of n plus x square. So root of n plus x square gets cancelled. So you get tan inverse of 1 minus for a lower limit tan inverse of 0. So tan inverse of 1 is nothing but pi by 4. So tan 45 degree is 1. So pi by 4 into integral 0 to 1 dx by root of 1 plus x square, and tan inverse of 0 is 0. So similarly for this also you have to apply the limit for integral dx by root of a square plus x square formula. So after applying you get pi by 4 into log of x plus root of x 1 plus x square between the limit 0 to 1. So after applying the upper limit and lower limit, you will be getting the answer as pi by 4 into log of 1 plus root 2. So this is our solution. Thank you.